This video is on actually figuring out the probability of something happening. So this is an example of theoretical probability. Again, theoretical probability is we do not have to actually gather the data. We can determine it from the information we're given. So this, for example, a bag contains 4 blue marbles, 6 green marbles, and 3 yellow marbles. A marble is drawn at random from the bag. The thing about probability is you have to have what you want out of the total. So that means we have to have the total. So there are 4, 6, and 3. So that is 13 total marbles. 13 total. You should always figure out your total. The first question is, what is the probability of drawing a green marble? So what we want to do is write out in how to write out the events. We want probability of, since we know we're talking about marbles up here, we know we're actually talking about marbles and we have the different colors. I just want to say the probability of a green marble. So just green. Probability of green. And you can also abbreviate this as P of G because that will stand for green. Now, we need to figure out how many ways a green marble can be drawn. So a green marble, there are 6 green marbles. That means that I could draw a green marble 6 different times. This would be 6 green. So that means my total number of ways that the event can happen, the event is green. The green can happen 6 times, 6 out of. Then we need to find the total amount of possible outcomes. Well, there are 13 possible marbles, so that means I have to divide this by 13. Then this is the probability in fraction form. Remember, probability is written as a number between 0 and 1, so we need to write it as a decimal. So if we plug this number in, we get 0.462. Now you should write the 0 point because if you don't have that 0 point and you just have the decimal, sometimes that decimal is hard to read. So you definitely want to see that 0 point. Your number should never be above 1 because you cannot have over 100% chance of something happening. So we know it's somewhere in between 0 and 1. And 6 out of 13 is close to a half. So we can see that this is close to a half, and it'll be a chance of it happening is half a chance, basically. Half the bag is green marbles almost. The next question says, what's the probability of drawing a yellow marble? Notice that it's just asking for one type of marble, so we can say the probability of just yellow because that's the color we want. So the probability of yellow, number of ways a yellow can be drawn. We have 3 yellow marbles, so there are 3 ways the yellow marble can be drawn. So that'd be 3 out of. And again, we have a total of 13 marbles. Now this does not say we have to pick one and then we don't have that marble in there any longer. This is just asking very basic, what's the probability of this just happening. So our probability is 3 out of 13, and again, we will put that into our calculator and get a decimal value between 0 and 1. We'd get roughly 0.231. So the probability is a lot smaller because there are a lot less yellow marbles than there are green. This next question is, what is the probability of drawing a green or a yellow marble? That or right there goes back to understanding the union. If we remember our unions, the first set, we write out all the possibilities of the first set, but then we also write out all the possibilities of the second set. So an or is just a union. So we can write this out as P of, we want green or yellow, so green or yellow, which again means union, so we can write out P of green union P of yellow. We want the possibility of green, but we also want the possibility of yellow. So in order to figure this out, we have to take the probability of green, which we had up here was 6 out of 13. But then we also want the probability of yellow. We want that 3 out of 13. Now, what this means is if I draw a green marble, that means I've done what I wanted to do. But if I draw a yellow marble, I've also done what I want to do. So I actually have increased my chances of doing something that I want or getting a color that I want. The only color it's not asking for is blue. So as long as I get one of these two colors, I'll be happy. So my chances have actually improved because I can get out either one of these colors. So what should we do to improve our chances with these two numbers? Because they have a common denominator, to improve our chances, we want our numerator to get bigger. By doing that, we have to add them. We add our chances. So that will become 9 out of 13. Now this number is much bigger than both the 6 and the 3, so it's actually getting us a better chance, which would be approximately 0.692. That's our chance of being happy with one of our marbles. Because as long as we get a green or we get a yellow, we'll be happy. Now this is actually called the addition rule of probability. I'm going to turn my paper and write that in here. This is the addition rule of probability. Addition rule of probability. Because we're dealing with OR. Unions, we want to add them. But we have to make sure that there is no overlap in them. Because just like in Venn diagrams, we want all of the marbles that are green, all of the marbles that are yellow, but we want to make sure we don't have to say any of them twice. Since there can't be an overlap between green and yellow, this is fine. There's no overlap. We would just have to subtract the overlap, just like in a Venn diagram. Now this next one is actual experimental probability. Experimental is actually gathering the real-world data. So suppose a study of car accidents and drivers who use mobile phones produce the following data. This is data that has actually been gathered for you, so you don't have to do the actual experiment, but we have to use the information given to us from the experiment. So we have drivers using a mobile phone and drivers not using a mobile phone. But we also have the information of had a car accident in the last year and did not have a car accident last year. Then as you notice, we have totals on both sides. So totals right here. These are actually the totals of this entire row. This is 325 people. So if you add 45 and 280, you get the 325. Then you have the total of drivers not using a mobile phone. So that's that 25 plus 405. You also have the totals coming down. So the total number of people who had an accident last year was 70. And then the total number of people who did not have an accident were 685. But down this bottom corner, this 755 is the total number of people all together. So you're not going to add the 70, the 685, and the 325 and 430. These two together give you 755, and these two together give you 755, because all of the people combined would give us 755. So these four boxes right here give us the 755, because these are the actual amount of people. These are just the totals of certain things. So this table is called a frequency table. But it can also be called a contingency table. It can also be called a contingency table. So the total number of people in the sample is, again, the total is 755. There are 755 people. The row totals, so that means going sideways, the row totals are 325 and 430. Whereas the column totals, columns go up and down, column totals are 70 and 685. And again, as I said, notice that 325 plus 430 gives us the 755. And 70 plus 685 also gives us the 755, because for these two, this is one type of information. This is accident or not an accident. You can either have an accident or not have an accident. Those will add up to the total number of people. And then you're either using a phone or not using the phone. It's one or the other. These two numbers will have to add up to the total number of people. Then you can have four different possibilities. You can have someone who had an accident and using a phone, had an accident not using a phone, did not have an accident and used the phone, and did not have an accident and was not using the phone. you have 4 possibilities because you can actually use the rows and columns to find where they match or where they meet. So we're going to calculate the following probabilities using the table above. We want the probability that a driver is a mobile phone user. So right here it says a driver. We want just a driver. Now all of these people are drivers because we have drivers right here. So we have 755 drivers. So that will be our denominator because we want the total ways, the total number of ways. We have 755 total drivers. But from these 755, we want of those drivers that are using a mobile phone. So these are the drivers that are using a mobile phone. It does not specify accidents or not, so we just want the total number of people that are using a mobile phone. This is the number of ways that we have a mobile phone user. We have 325 mobile phone users. We just want to know the probability that a driver is a mobile phone user. So you can look at it as the beginning part actually tells you your denominator, and the next part will tell you your numerator. So if we put this into our calculator and we get it down to a decimal, it's roughly 0.430. The next one says the probability of a driver had no accident in the last year. So we want to talk about drivers. Again, there are a total, all of these people are drivers, so we have 755 total drivers. But then we want had no accident. This does not talk about using phones or anything like that, so it's just talking about accidents. So had no accident. So we want to say accident, no accident. We want all of the ways that someone did not have an accident. We had 685 ways that someone did not have an accident, regardless of using a phone or not. So we have 685 people who did not have an accident. So if we round that, put it in our calculator, get a decimal, 0.907. So again, we have the beginning part would be your denominator, and then the last part with no accident in the last year would be your numerator. This last one is the probability that a driver using a mobile phone had no accident in the last year. This time it talks about both different cases, so this one we have to be more specific on. It's talking about a driver using a mobile phone. Not just a driver, but a very specific type of driver. The more specific you are, the smaller the number will become. A driver using a mobile phone. So we want drivers using mobile phones only. So this will be your total number of ways that it can happen. Drivers using a mobile phone. We have 325 drivers using a mobile phone. But because we are specifically only talking about these people, that means we can't look anywhere else in the entire chart. We have to specifically look at these people. Because we were talking about earlier, we were talking about all the drivers, we can look at all 4 types right here. We can look at all of the numbers. But because we're only focusing on drivers using a mobile phone, we can only focus on this row. We want from that row that had no accident in the last year. So from this row, the drivers using a mobile phone had an accident, did not have an accident. So we want the people who did not, no accident, did not have an accident. There are 280 people who did not have an accident, but were mobile phone users. So we have to be very specific on this. This is conditional. Very specific. So if we round this out, give us approximately 0.862. And that's the probability that a driver that was using a mobile phone did not have that accident. So again, you have to be very, very specific. If you end up using both of the terms, so we had accident and mobile phone, you're going to end up having to use one of the rows or columns. So this one, driver using a mobile phone, those are all the people we wanted. But then we want to go specifically to the ones who did not have a car accident.